Okay, so as you know, this is the last question and answer period. And so I'll answer your questions. The final exam, remember, it will be comprehensive. It will include all of the material before the midterm, emphasis on the post-midterm material, Ethereum, but there will be some coverage of the pre-midterm material. The lectures for this week I just uploaded to YouTube, so they'll by the time the class is done, within an hour or so, I'll post them. I won't test you deeply about them because you don't have a chance to ask me questions, although you can still ask me by email or ask me during office hours. But I will at least test you on, expect at least one question per lecture just to make sure that you actually watch them. And the other thing I still have to do is I'll add the slides for last week and this week to the notes so that you have a copy of them with the whole notes as well. So those are the two things I'll change. Someone asked over email whether the exam could be put on Moodle, and I would actually prefer it. It's easier for me, but the department insists on in-person exams, and so I can't control that. So it's unfortunately for all of us, it will be an in-person exam, and the main reason they do is because of cheating. So they want to. I can write an exam so that it's reasonably hard to Google an answer, but I can't stop you from asking your friends or asking someone who took the course last year or whatever. And so yeah, so that's the department's concern, anyways. But I would prefer Moodle's a lot easier. I don't have to mark it, or it cuts down on the marking. I don't have to print off the papers, which actually takes an hour. I don't know if you realize that, but you have to go and print them off, and then if the printer doesn't work, you have to make sure you do it a couple days in advance. And anyways, this whole exam business and then marking, and even if you flip to the right page, if you have 70 exams and you want to flip them all, it takes at least 10, maybe 15 minutes just to flip every exam to the third page, for example, because you have to physically touch everyone. So whatever, exams, marking, not fun. Okay, and then your projects, I put it on the website as well, so you can hand it in anytime before or including April 22nd. All right, so that's what I wanted to say. Now I'll take whatever questions you have about the course material or the exams or the projects, whatever you want to know.
Yeah, like you said, the exam will mostly cover the second part, after the midterm. So does that mean very few questions?
No, it'd be more like maybe 2/3 after and 1/3 before. The problem is because of the midterm, I shifted at the last minute, and then I didn't know that everyone could do it on Moodle, so I gave the option to not write the midterm. So there were a few students who took up that option, and so they have not been tested on the pre-midterm material. So it's actually not, if you wrote the midterm, it's not fair to you to have students that only had to learn half of the course and not the whole course. So that's the reason why it will be a comprehensive exam. And yeah, Bitcoin will be significant. It's not going to be just one question. It's going to be but it won't be half of the exam or more than half of the exam.
Yeah. The project that we're working into 22nd, so at what time can we expect the final grade to come out?
It takes 2 weeks. So I think this is after the exam, right? Yeah, so it'd be 2 weeks from the 22nd.
So is there a chance I can get an early grade, because I'm starting my job in the first week of May,
Mm-hmm.
and to do that I have to get my completion letter from Concordia to be able to apply for the work permit. So is there any chance I can get an early grade or something like that?
So this is something to email me about, and I can probably, if you can make it clear when you need it by, and it also depends on how official the grade needs to be, because so students also have this mental model that as soon as I put the grade in, it gets posted to your transcripts, and that is not the case at all. So I submit the grades as a class because they want to see the average. Then it gets approved in CISE. Then it gets sent to the dean's office. They approve it. Then it gets sent to Concordia. They approve it. And so, so when the grades leave my possession, that doesn't mean anything. It could still take a couple days or a week, to go through all the layers of approval and things like that. So if you're can you tell me unofficially what my grade will be? That's easy. But if you want me to push your grade through all the levels early, I can't guarantee it. I can try, but I can't guarantee it. Yeah. And then in your case, if you submitted your project earlier, that would help as well. Because, yeah. Then I can, well, anytime after the exam is fine. But once if you send me an email about it, anyways, there's also a complication of whether the system would let me submit a single student's grade without all of them. And I don't remember the answer to it. So, yeah. But anyways, students that are close to graduation, they want the grades faster, so that would apply to your case. And it also affects when you convocate and things like that. So, yeah. Anyways, it's complicated, the whole process, but sure. Other questions?
In front running lecture,
Yeah.
so when you talk about tokens, what do you mean exactly? Does it mean like new cryptocurrency or like specific of company? What does it mean?
Yeah, right. So first off, I apologize. The last two lectures, I probably should have switched the weeks. So the lectures that I'm posting now, you probably should have watched first, and it would have made more sense. But even in those lectures, I don't really clearly define what a token is. That's something that maybe is a good addition for next year. But a token is a custom currency, usually on Bitcoin itself. So on Ethereum itself. So on Ethereum, you have your onboard currency, which is called ETH, right? And you have the ability to create a smart contract. And so one of the smart contracts you could create is a token accounting system. And so there's a common library that's used, or a standard called ERC20, and then you can get libraries for it. And so even on the user interface, I don't know if you noticed it, but on the original Ethereum one, which isn't maintained anymore, they actually have a button where it's like create a token. And they're just like, okay, what do you want to call it? How many do you want? And then you press a button and then it's created or whatever. But all it is a smart contract, and it has, however many tokens there are. And it basically has a big like spreadsheet of like, here's a account balance and here's how many tokens they own, right? So like the first time when you create it, maybe the contract owns all of it or you own all of it. And then as you give it to new people, then the list grows. And so that's all it is. Now, what a token represents and what you can do for it or do with it, that depends. So the main cases are, there's what are called utility tokens. So let's say I set up a system. To use my system, you have to pay a fee in my token. Yeah? So then it would be utility token because you would be buying that token because you want to use my system. If you don't have the token, you can't use my system. Sometimes tokens are used to vote. So you might have a project where there's different, like, let's say it's an exchange and they're like, okay, let's vote on what new tokens we should support on our exchange. Then there might be a token and you can vote. And if you have 5 tokens, you get 5 votes. And if you have 100 tokens, you get 100 votes. And then whatever one vote like wins, that's a change that's made. So those are called governance tokens. And then sometimes tokens are stapled to real world things. So these are, or maybe to the equity in a company or something like that. So they're called security tokens. And they, like the most common example, which there's a lecture on, are what are called stable coins. So you might have a company and they might lock up $1 million, and then they might issue 1 million tokens. And they'll say every token's worth $1. We have $1 million in the bank, and each of these tokens is worth one of the $1 million that's in the bank. And so it's kind of like having a US dollar or a Canadian dollar that's on the blockchain. And if you ever want to redeem your token for one of the real dollars, you can do that. And so, so you can do your custom currencies. Usually because ETH, you still need ETH because you have to pay the gas fee, right? So everyone has ETH, and then they have some other token if they want to use some other system. Yeah. So it doesn't compete directly with ETH because you can't pay your gas fees in it. But usually it's for some purpose that ETH doesn't cover. Or it's like more for a specific project or something like that. Yeah.
So in the refi section, you had mentioned something regarding flash loans.
Yes.
So let's say a user gets the loan and they spend it on something. And for example, transaction is reverted.
Yeah.
So won't this affect the transactions down the line? Like,
Right. So let's walk through an example. So this is important to understand. So in Ethereum, only one transaction can run at a time. Okay. So let's say I take out a loan. Okay. And now I have the money and I give it to you. Right. So I send it to you. Okay. Then I go and do whatever. Okay. And then it's time to repay the loan and I don't have enough money. Right. So, but you've already got the money. Right. Now, the problem is, well, what if you spend it, for example, before I'm able to decide that I can't repay the loan, right? Then do I take the money out of your pocket, right? Like what happens? And so the answer is very simple. It's how do you spend the money? If I sent the money, how do you spend it? You have to send a transaction. Your transaction will happen after mine because mine's still in the middle of running, okay? So there's no way for you to spend the money without my transaction completing, and by the end of the completion of my transaction, you'll figure out whether you got paid or not, right? So you don't know really whether you got paid or not until my transaction completes. Forget about flash loans. There's all sorts of things where there might be an error right at the end of the transaction, and then the whole thing reverts, right? So you're never really confident that anything happened until the transaction finishes, or maybe it runs out of gas. Right, that's a better example, right? So everything about the transaction is right. I'm paying everyone in the room, so I pay you, I pay you, I pay you, I pay you. I run out of gas, right? And then all of a sudden they're like, okay, we're throwing the whole thing away, yeah? And so it's fine because in order for you to spend that money, you have had to do a transaction, and that would be after my transaction. So it doesn't mess anything up like reverting a transaction as long as only one transaction runs at a time. Yeah, does that make sense? Yeah, so that's why a flash loan is possible on Ethereum, but you can't do it in real life because in real life you can't say only one financial transaction happens at a time because anybody could do anything anywhere in the world, right? You can't, yeah, so you can't operate that way. Other questions? Yeah.
So, Professor, in Reentrancy attack, you explained one like a cure of it that we can choke the gas limit.
Mm-hmm.
So, can you please explain that part again? How can it help like limiting that gas limit so that we cannot like the reentrancy do not occur?
Sure. Okay, so reentrancy is kind of complicated. I won't go through the full details of it. You'll have to watch the lecture to get the full details of it. But essentially what happens is every time you transfer money to someone, what happens is that person, if it's a contract, if it's a simple address, then it just goes through. That's fine. But if I send money to a contract, Ethereum says, hey, that contract is allowed to run some code. And the idea was in their minds that maybe it wants to like make a log of it or fire an event or something like that. Okay, so what we're going to do is I'm going to send money. Ethereum's temporarily going to give them the ability to do some stuff. And then control will come back to my program, and then it will go to the next line after I transferred the money. Okay. Now, it turns out that it's dangerous because if I give control to someone else, they could write code and they could say recall the same contract, and then you get this loop where they keep calling the same contract over and over. And maybe I'm not updating their balance until after I transfer the money because I want to make sure the money went through before I update their balance. And so they're able to withdraw the same money a whole bunch of times, right? And then eventually they give control back to me and then I update their balance, but I think they only did one withdrawal. So that's effectively what reentrancy does. Now, remember, every line of code you have to pay gas for. Okay, so who's paying the gas when I throw control to this other contract, right? The person running the function, the original person running the function, they're paying for everything. There's no one else around to pay for it. And you can't reach into a contract and take money out for gas. Like gas is pledged by the person that initiates the transaction, right? So if you call a function that sends money to someone else and that someone else runs some code, you're paying for the whole thing. Okay, you sent that transaction. So it's not maybe the best way, that it could work, but it's sort of the only feasible way that it works. So, okay. So then what people said is, well, that's really dumb. I don't want to pay the gas for like some other people to run. Okay. So then what Ethereum said is, okay, no problem. What we're going to do is we're going to give you control in your transfer function where you can say, yes, you're still going to give control to this other person and they can run whatever they want, but you can put a limit on how much gas they use, right? So you can say they don't use any more than a certain amount of gas, okay? Then what happens is, so how does it solve reentrancy? Well, if you call into their contract and they're allowed to run something, and let's say they're going to call back into your contract, doing a call takes a certain amount of gas. So as long as you make your limit less than what it calls, like what an external call costs, then you can ensure that they can't call anyone. Okay, so what you do is you effectively set the gas to zero. You don't set it quite to zero because you give them a little gas so that they could do stuff like log things or fire at events, but you don't give them enough gas to actually make a call, and then that's what solves the reentrancy loop. Now the problem is, okay, then the further thing is, well, why don't we just by default not give anyone any gas when we transfer things? And so the problem is that until reentrancy people learned about it. Actually, let me put it another way. Okay, what happens if you say you only get a small amount of gas? So you give control to the other person, and they try and make that function call anyway. Then your whole transaction, basically your call runs out of gas, and then effectively your whole transaction runs out of gas, and then it completely reverts. Okay, and so because they can't change their contract, because once you post a contract, you can't change the code. So if their fallback function always tries to call another function, even if they're not attacking you, they're just doing it. If your contract doesn't give them enough gas to do it, then you can never send money to that contract because it will always revert, and neither of you can change your contracts. It's too late, right? And so everything gets locked up. It gets deadlocked, right? So that was the concern with this, is that there were a whole bunch of people who had already deployed contracts that were already doing stuff in the fallback function, right? And if we just stop giving gas for fallback functions, then we're going to lock out all those accounts. Basically, we can't deal with those accounts anymore. They're not going to be compatible. So there's a compatibility issue. So for a while, people tried to solve reentrancy other ways, like just checking or making sure you update accounts before you transfer the money. And there's different design patterns that you can use to make sure that you're not vulnerable to it. But then Ethereum drilled it into people's heads that, like, if you ever do a new contract, you should not put anything in your fallback function, because there's a good chance that people aren't going to give you the gas, and then you're going to be locked out from anyone that has a standard transfer. And then over time, as new contracts came out, nobody did anything in the fallback function. And so now it's like basically just assumed that if you're dealing with a smart contract, they're not going to have anything in their fallback function. And yeah, it's at their own peril if they do. And so, yeah, so it took a couple years. So now it's standard that you don't pledge any gas when you make that call. Now in Solidity, you could say, okay, well, how do I change the amount of gas, right? And so at Solidity, remember, it's a high-level language. So the amount of gas is actually specified in the opcode, right, in the EVM bytecode. Whether Solidity allows you to change that or not is up to Solidity. So what Solidity can do is they can say, hey, we're going to have a transfer function. We're going to call it transfer, and it's always going to have this amount of gas. Like, the developer can't even change it. As long as they write transfer out, it will always compile down to this bytecode where this is the amount of gas that's specified. So that's why there's differences in Solidity between send, transfer, or they have a way that you can actually do a call where you give all the parameters. If you really know what you're doing, you can do all the parameters. But they just give you a prepackaged function that has a certain amount of gas. And then they can change that too. So Solidity can say, okay, now, transfer used to give you this much gas. Now it's going to give you this much gas instead, or whatever. So they can make those changes themselves. And it doesn't affect Ethereum because it affects the compiler from Solidity down to bytecode. Yeah. Yeah. So if you want to do the full thing, this is in Solidity. This is how you do it. So you can specify all of the different things, or you can just use send, or you can just use transfer. Okay, other questions? Yeah.
Yeah, lecture in the part of the decentralized exchange,
Mhm.
you mentioned two terms. One is on-chain, one is off-chain. What are they exactly?
Yeah, sure. Okay, that's something maybe I should define better. So on-chain just means it's running on Ethereum. So it's in a smart contract. And then off-chain would be like I just set up a website. So I can set up a website. It's not running on Ethereum, but it accepts Ether. So I just say this is my address, and you can send Ether from your address to my address. So you use Ethereum to do that transfer, but then the whole functionality of my website is just, it's running on a website itself. So we call that an off-chain. It's just a standard, basically, web application. Yeah. And so the idea of an off-chain exchange is that you, like, let's say you have Canadian dollars and you want to convert it to ETH. The exchange can't reach into your pocket and pull Canadian dollars out. And it can't reach into your Ethereum address and pull ETH out, right? So you have to give your money to the exchange. So basically you give it to them and they say you can withdraw it at any time, right? But they own it, right? It's in their custody. So you give your money, your ETH to it, you give your Canadian dollars to it, then you can exchange it, and they own all their users' ETH and all their users' Canadian dollars, and then they're just moving money around amongst their users, yeah? And then at any time you can go and you can withdraw from it. Now it's dangerous because they own it, they could just run off with the money, right? And that has happened. Or they could get hacked. So someone could hack in and steal all the money. And so now it's gone, right? And now you can't withdraw because they don't have the money themselves to give you. And so, yeah, both of those things have happened repeatedly with centralized exchanges or off-chain exchanges. And so then what people said is, well, could we do an exchange just in a smart contract? Then you don't have to give your money to it. Or if you give your money to it, you can at least read the source code and you can see that you can get it back, or that it can never like lose your money or whatever. So we call it non-custodial, which either means you don't give your money to it. It basically, you allow it to reach into your wallet and grab the money if it needs to do an exchange, or you at least read the source code and you verify that there's no way to get the money out otherwise. Yeah. And so that was why people moved to on-chain solutions. They're also like kind of simpler. You don't have to like deal with a website and set up an account. Legally, they're not as regulated because they don't exist in any country. They're on Ethereum. And so no country can go in and say, well, I'm going to regulate them. Now, sometimes there is a company that backs them. So like someone will put the contract up and then there'll be a country that's based in the United States. And then the US government will say, okay, we're going to regulate you, right? But at the end of the day, it's just source code. And so anyone could take a copy of it or something and put it up. And you don't know where it came from. It's just running on Ethereum. Whereas centralized exchanges, they are businesses. They have to have bank accounts because they're receiving, fiat government money as well as cryptocurrencies. And so governments will regulate them. And so you have to, you can't just instantly use one. Like if you go to Coinbase, you can't just instantly use it. You have to upload your passport or driver's license, and it has to be validated and things like that. And that's all to comply with different government regulations. That's why people use on-chain stuff. Now the problem with on-chain is that it's really slow and expensive. You pay in gas fees. So for example, if you use Uniswap, which is the biggest one, it's a really dumbed down version. Like it doesn't give you the full functionality of an off-chain exchange. But even in the most dumbed down version, if you use it, it could cost, I haven't checked recently, but like as of a couple months ago, it would be about $100 to $200 to do a swap. So if you want to buy $20 worth of a token, you would never do it because you're going to pay $200 in gas to do it, right? This is Canadian. And yeah, so unless if you're spending even if you spend $1,000, $100 is 10%. That's huge, right? That's a very large fee, right? So if you're doing $10,000, then it's 1%, and you're maybe like, that's not bad, because gas costs are fixed, right? They don't care about how big your transfers are. So anyway, so that was another push or that was a push away from on-chain. Then there was a middle road solution where people said, well, maybe we can make Ethereum faster. Maybe we can pull a bunch of stuff off Ethereum, run it on some other system, and then you can always push it back to Ethereum if you want to. So these are called layer 2s. And so now that's like the kind of current approach where most people will use these layer 2 solutions, and you got to go through a bridge where you bridge your tokens off of Ethereum onto the layer 2. Then layer 2 is really cheap, and then if you ever want to pull it back to Ethereum for whatever reason, you can do it.
Sorry, also exchange cryptocurrency to another one, like how do you network? I don't understand. So do they change to the fiat and then change fiat to the new cryptocurrency, or just change it with each other?
Yeah, so a centralized exchange will just exchange it with each other. So if I offer Canadian dollars and 50 tokens, I have a whole bunch of people that like if you want to sell one token for another, I basically am going to match you to someone who wants to do the opposite trade. So they have the other token and they want the token that you have, and then I'll say, okay, you two match with each other. Now you can always go to fiat if you want. So if there's not a lot of liquidity between two pairs, then you could convert first to say Canadian dollars and then go from Canadian dollars to the pair, right? And it shouldn't be cheaper to do it. Otherwise, there's what's called an arbitrage opportunity. And so, but anyways, yeah. So you basically are going to be matched with someone that has the opposite intent. But you as a trader, you can convert to a third currency, and then from the third currency, you can do whatever you want. Yeah. And with on-chain exchanges, because if you have 50 tokens, you need like 50 choose 2 different pairs, right, between all the different kinds of pairs, and that's too crazy. So in on-chain exchanges, they actually made you convert to a common currency, which was usually ETH for Ethereum. So you couldn't go directly from one token A to token B. You had to go from token A to ETH and then ETH to token B. And that's just because then you only have to set up 2 exchanges instead of one for every possible pair of tokens. Now the way they work is a little more complicated. They have these big vaults with a whole bunch of mix of tokens, and they try to give you more direct options if you want them. But anyway, but the protocols get more complicated.
And the application should be in Ethereum or should be in all of the blockchains? For example, if someone wants to exchange like parity to Bitcoin,
Yeah.
it should be in all of the blockchain. Or?
Okay. So what if you want to? So Bitcoin runs on its own system. ETH is on Ethereum, which is its own system. What if you want to trade Bitcoin and ETH? So you have 2 options. One option is you can go to a central exchange, right? Because then they have a bunch of ETH and they have a bunch of Bitcoin, and they switch it for you. So that's fine. What if you want to do it on chain? Well, which chain are you going to do it on? If you do it on Bitcoin, there's no ETH there. And if you do it on Ethereum, there's no Bitcoin there, right? So it seems that you can't do it on chain. But then what people said is, well, what if I know there's no Bitcoin on Ethereum, right? But what if I locked up $1 million worth of Bitcoin and then issued $1 million worth of a token that we'll call like Ethereum Bitcoin, or the technical term, or the term they actually use is called wrapped Bitcoin. So it's like Bitcoin that's wrapped for Ethereum. And to a certain extent, there is some trust, but you can set it up so everyone on Bitcoin can see that the number of tokens in circulation on Ethereum exactly matches the number of Bitcoin that's locked up, by the company on the Bitcoin side. And so that was the solution that people came up with. So most people work on Ethereum because it has smart contracts. You can actually do an exchange. It was the first. So and then over time, it's built up the most value. So if you want to go meet other traders, right? So you want to go to the biggest exchange possible where the most other traders are. And the best place to meet other traders is on Ethereum because that's where the most of the people are. So there is a kind of network effect. But there are some other chains now that are building up like sizable users. But anyway, that was the solution. So they take Bitcoin, they wrap it. Basically, a company does it, they wrap it, they issue tokens on Ethereum, and then you're not buying actual Bitcoin, you're buying a token that represents one Bitcoin that's locked up on Bitcoin. And then if you want to redeem it for Bitcoin on the Bitcoin chain, then you could do that. Other questions?
Sure. Is that also how like AMM works?
Yeah, so AMM is the exact way that they do the swap. So normally if you, let's say I want to buy ETH for Canadian dollars and you want to buy, actually let's keep it on chain. So I have another token, well let's say I have a stable coin like DAI. So I want to buy your ETH and you want my DAI. DAI is like tied to the US dollar. Normally what you would do is you'd run what's called an order book. So you would post, one of us would go first and we would post the price. I'm willing to, give this much DAI for this much ETH. You would look in the order book and say, hey, I'm willing to do that deal. And then the exchange would match us. Now the problem with that is that anytime you have to look through, like say a book and you have to walk through, it's a linear time operation because you have to look at the one price and the next price and the next price. Or if someone wants to put a new order in the book, you have to find the right place in the book to place it. And so that's like really simple for a computer to do. But for an Ethereum smart contract to do, it's not simple. It requires a lot of gas. It's simple, but it takes a lot of gas. And you have no control over how big the list can get. And so you could eventually run out of gas. So even an order book, which is just simple insertions and removals from a list, ends up being way too expensive to run. And so what people said is, okay, we'd still like to do this exchange, but we need a better way. We need a faster way of doing it. We need something that's constant time. So then AMMs is a solution to it where basically what happens is you put up a contract that's kind of like a vending machine. And it has a big pile of ETH and a big pile of DAI. And it has some mathematical ratio. And so if you want ETH, you put in DAI. So you put DAI into the vending machine and then it gives you ETH out at a certain rate. And the more and more ETH that you take out, the rate gets like more and more expensive. It requires more and more DAI in order to take the ETH out. And technically it will never run out of coins because the price will go to infinity. And so, and then conversely in the other direction. So basically it just has a big pile of coins. And then, if you put one kind of coin in to take the other kind of coin out. And it gives you a price. The price is on this curve. So there's different curves that define it. The easiest is called the constant product rule. But anyways, and that's how it works. Now the problem with it is it's uninformed, meaning it doesn't know what the true price is between the US dollar and DAI, between ETH and DAI. So it will always have the wrong price. It will always have an old price. It will always be stale. It never has current information. And so it basically loses money on every trade. So this is called impertinent loss. And but it makes up for it in fees. So every time you interact with it, you pay a fee. And so they're basically betting that you'll make more in fees than you'll lose by having bad prices. And so empirically, it seems that actually it tends to lose more than it makes in terms of fees. And the other thing is who's putting this machine up and who's putting the money in the machine. So the other side, the flip side of AMMs is that someone will put the contract on Ethereum, but they won't fill the machine. What they'll say is you guys could fill the machine. Anyone who wants to can fill the machine. And then the fees that it's generating go to the people that put the coins in the machine. So you have to put two kinds of coins. So you put a pile of DAI and a pile of ETH, you put it in the machine, and then later you can come back and withdraw them again as a pair, and you'll get it at the current, whatever the new exchange rate is that you'll be able to withdraw them. So this is called liquidity providers. And, And then there's more complicated versions, like Uniswap version 3 allows you to say, I'll only put coins if the price is between these two values. Once it gets outside of these values, don't use my coins anymore. And it lets you have some control over when your coins are used. Yeah. But the big problem is if you put your coins in, and let's say one of the tokens goes to 0, right? Then they're going to drain the system of the other token. Like say you put ETH and you put some garbage coin in, right? They're going to drain the system of ETH, and you'll just have a big pile of garbage coins and no ETH left. So when you go to withdraw, you have no money. You just lost all your money essentially. So they're dangerous to use. They're not riskless to use. You'll get a fee for that person like draining it, but it's never going to offset. So they tend to work well when prices are relatively stable, but if there's large swings in the price, then the people who put the coins in tend to lose money. Other questions? No? All right, good. That's it. Bye, everyone. No, good luck on the exam, and I hope you like the course. Say again?
Could you tell more about the final exam?
Yeah, so it will be a mix of multiple choice and short answer. It will cover the whole course, but the emphasis will be on the stuff after the midterm. Yeah, on the Ethereum. So kind of like 2/3 Ethereum, 1/3 Bitcoin kind of thing. Yeah, and I haven't decided. I might do the multiple choice on a Scantron form. So those forms where they have like all the circles and you have to like pencil it in. It allows the scanner to mark it. So I may or may not do that. I might just have you circle on the exam sheet itself. I have to decide. But it'd be useful if you bring a pencil. And just in case I do the Scantron, and if you are writing an exam anyways, pencil's good. Sometimes students are scared because I guess at some universities you're not allowed to use pencil or something, but here, use it because you want to erase your answers and be able to rewrite them in case you want to change things. Can I put which?
22 is with the deadline for the submission.
For the project, yeah. Yeah, that's right, yeah. So I'll accept the project up to 22 anytime without penalty. Yeah, the exam will be, we have a 3-hour window. I try to write something that's maybe an hour and a half or 2-hour exam, but if you want to sit for 3 hours, I won't kick anyone out. And so every year there's someone that leaves after 30 minutes, and then there's someone that leaves. Not because they didn't understand it, but they actually did understand everything and they just flew through it. And then there's someone that's still there at 3 hours, right? And then even then I'm like, okay, you have 1 minute left, and then they're scrambling, writing stuff. So don't be that person, please.
So the short answers questions will be similar to the ones you uploaded for the midterm, right? The sample questions.
I can't remember, it was so long ago, but let's say yes. So other than the fact that if they were midterm questions, they would only be on Bitcoin, but they would be similar. Yeah, it will be I'll try and do as many multiple choice as possible. It's just easier to mark. And then if something's too complicated to distill into multiple choice, then it would probably be a question where you explain how something works, right? Yeah, so the midterm, some students asked about it during the midterm itself because they were practicing on it. So there was one on how the UTXO pool changes. So that's the kind of thing where it's sort of a transaction comes in and then you take an output and you cancel it and you put a new output there, that kind of thing. Yeah. All right. Okay, good luck. It's been a pleasure. And I hope to see you in future terms for those of you who haven't taken either this course or 6150, because that's all I teach.